Irodov problem number 1.237. Three forces are applied to a square plate as shown in the figure. Find the modulus, direction and the point of application of the resultant force if this point is taken on the side BC. So let's draw the diagram. So here is a square plate. Okay. This is point A, point B, point C and point D. There are three forces acting, F, and along this F root 2. So first thing is resultant force. So I can write F net. Let's suppose this direction is x and this direction is y. Okay, so this force we can write as F j cap in the y direction plus this force we can write as F I cap, and this force we can divide it into two components, one along I direction and another along minus j direction. So F root 2, so this angle will be 45 degree. So if I make this a component, this side will be F root 2 divided into 1 by root 2, so F, and this side will also be F. Okay, so this becomes plus F I cap and this becomes minus F j cap. So j gets cancelled, so this is 2F I cap. So modulus of the resultant force is 2F and direction is along x-axis. Okay. Okay. Now let's suppose this point is O. If the side is A of a square, then this diagonal is a square plus a square 2a square, square root of that. So it will be root 2a. So half of this OB will be a by root 2. And OD will also be similarly a by root 2. Okay. What we can do is we can find out tau about O for due to these three forces. So due to this force, it will be force times perpendicular distance. Force times perpendicular distance is a by root 2. And this is turning it clockwise. Let's suppose clockwise is positive. This force is also turning it clockwise, so plus F, again the perpendicular distance is a by root 2. This force is turning it anti-clockwise. Now we have to find the perpendicular distance. So perpendicular distance will be this distance. So if this distance is a by root 2, this is a by 2. So how much is this perpendicular distance? This is half of this side, so this should be a by 2. Okay. So the torque due to this is F root 2. So we'll do a minus because it is anti-clockwise. F root 2 times a by 2. Okay. So let's calculate the net torque. So this and this gets cancelled. So net torque is Fa by root 2. Okay. Now we know the net force is in the x direction. Okay. and the torque about O is Fa by root 2. So we can write this as F net times R perpendicular, or we can write this as Fa by root 2 equals F net is 2F times R perpendicular. So R perpendicular, or arm of the force about O, is A by 2 root 2. Now, if the resultant force was acting on the side BC, okay, if the resultant force is acting on the side BC somewhere, let's say this is my F net, which is equal to 2F, the arm would be what? Would be this distance. And that distance we found out as A by 2 root 2. So this is A by root 2, half of it. So if it is acting half of it, so this BC, it will be right at the center of BC. So the answer to the question, if the resultant force acts on BC, if F net acts on side BC, it must be acting midway on BC. Midpoint. Okay. So that is our answer.